Okay, everyone mute yourself. Okay. Today's lab will be designing a 4-bit subtractor. 4-bit subtractor. In our previous lab, we have done a designing a 4-bit adder, right? We have done an adder. Okay, what was the adder? Okay, let's add the. Okay, let's see the adder, or let's open the adder. This was the adder, right? We designed last day. Now here, I want to save it. D25 subtractor. Just sub. It can do the subtraction, right? Now this one has an adder. This one is an adder. It will add the numbers, and the one we want to make, that will be a subtractor that can subtract. Now remember, computer cannot do the subtraction easily. It cannot do the subtraction very easily. It has to use a very special technique called 2's complement. 2's complement technique for subtraction. Now normally the minus number, minus b, is written as plus b bar plus 1. Minus b is equal to plus b bar plus 1. So a minus b will be a plus minus b. That means a plus b bar plus 1. So you can say a minus b is equal to what? A plus b bar plus 1. A minus b is equal to a plus b bar plus 1. So the computer can do the addition, but it cannot do the subtraction. Okay. Whereas using the 2's complement, you are actually doing the addition, not the subtraction. So what you have to do? You have to change the b to b bar, and you need to add an external one, an extra one to your result. That will give you the result of a minus b. There is a technique. This is called 2's complement. See, the technique is this one. This is the technique. So here this is your A3, A2, A1, and A0, and B is B3, B2, B1, and B0. What you have to do? You have to change it to B bar. That means B3 bar, B2 bar, B1 bar, and B0 bar. And you need to add 1. That means what? Okay, let me show you one thing. A note. So let's do an addition, right? Not this. Let's do one addition. Let's go to the word. Let's do an addition. 1. Okay, it's just too small. I need to make it big. Okay, 1101 minus 1 0 1 1. I want to subtract these two number from these to these, right? So what will be the result? Your result will be 1 minus 1. 1 minus 1, your final result will be what? 0, right?
Yes, sir.
Your last digit will be 0. So 0. Okay, let's say this is your result. So 1 minus 1, that is your 0, that is your result. 0 minus 1. So what will be the result from 0 minus 1? Remember, you have to make this 0 1 0, because you have to consider this 0 as 1 0. 1 0 means 2, right? 2 minus 1, your result will be 1. Here the result will be 1, remember. Okay, then since you take a 1 here extra, so 1 will be there. So 1 minus 1 will be 0. 1 minus 1 will be 0. So your result will be 0 0 1 0, right? This will be your result. We know it.
Yes, sir.
Okay, now let's do it in another way. So 1 1 0 1, that is your A. That means this one, that is your A. We will consider these as it is. Then your B, that means this is your B, right? Your B needs to be changed to B bar. B bar means your 1 will become 0, your 0 will become 1, your 1 will become 0, your 1 will become 0, right? This is your B bar. And additionally, you need to add an extra 1.
Add 1.
Extra 1, right? Okay. Now, if you do the addition, what will be your result? Okay, let's give some space. Okay. Now, if you do the addition now, not the subtraction, addition, what will be your result at first? Something like that. Okay, so see, 1 plus 0 plus 1, what is your result? 1 0, right? That is 2, that is 1 0. So 0 will be here, you have one more 1. So 1 plus 0 plus 0, your result is 1, right? Okay. Now 1 plus 1, your result is 1 0. 1 0, you will put the 0, you have 1. 1 plus 1 plus 0, your result is again 1 0. So you will put the 0. And you have one more 1 left. That 1 will come and sit just in front of this. Here, right? Here. It will sit here. Now see this one. We have to ignore. We have to ignore these 1. We have to ignore. Why you have to ignore? Because this is a subtraction. In the subtraction, if you subtract 4 digit from 4 digit, your result will not be 5 digit, right? That means you made some mistake somewhere. That's why you have to ignore the first digit, that is the carry out. You have to ignore. See, if you ignore this, your result is 0 0 1 0. That is exactly like your subtraction, 0 0 1 0. So that is the 2's complement subtraction. So you have to ignore the first, you have to addition, you have to do the addition, and you will get your result. We haven't done subtraction, we have done the addition, but we still got the result. That is the 2's complement thing. So you need to give the A is A will become A will remain as A, no B, nothing will be changed. B will be B bar, so B3, B2, B1, and B0 bar, everything will be bar. And you have one more extra 1, extra. This is the extra 1. Can you see the extra 1? This is the extra 1. So 1 plus A0 plus B bar 0, you have S0. So carry out will go to the next point because it is the addition. So C0 plus A1 plus B1 bar. So you have S1. The C1 will go to the next place. So C1 plus A2 plus B2 bar, S2. C2 will go to the next. So C2 plus A3 plus B3 bar will become S3. Your carry 3 will be ignored. See, ignored or grounded. That is the thing. So let's change our adder circuit to the subtractor. Remember, your A, this is your A. Your A will remain as A, no change. Your B will be B bar, right? Your B will be B bar. So let's take it here and change it. How? Delete, delete, delete. Now we will introduce some not get, copy it, copy, not get, 4 not gets, right? So because we want to bar it, B bar, so B3 bar, B2 bar, B1 bar, B0 bar. Oh no. 1, 2, 3, 4. Make the connections. 2, 3. So our A is A, our B become B bar now. So okay, B bar now. Now one more extra thing we have to do, we have to add one, right? Now where we will add our 1? Where we will add our 1? We will add our 1 at the A0, B0, right? A0 and B0. That means at the first LSB, not MSB. We will add 1 at A0 and B0. Remember, with A0 and B0, because other bits are occupied because carry is there, carry is there, carry is there. So they need a full adder, full adder, full adder. Previously, they need a half adder in case of addition, right? Now they need a full adder. That's why I told you to use one full adder here, right? I told you in the previous class, use a full adder here because we will need that later. That is the need, because I want this circuit to be changed to a subtractor. So we need to add one here. See, because this is A0, this is B bar 0. This is the one we will add. So what is 1? 1 is actually this one, not the ground. The power. This is 1. So let's take it and connect it. So here you have A0, B bar 0, or B0 bar actually, A0, B0 bar and 1. Here you have A1, B1 bar and the carry. Here you have A2, B2 bar and a carry. Here you have A3, B3 bar and carry. Remember, I told you to ignore the last carry, right? I told you to ignore. Ignore means?
Yes, sir. Grounded.
Ignore means disconnect it. Disconnect it with the display, from the display actually. And if you want, you can make it grounded. If you want, make it grounded. That's it. Make it grounded. That's it. Now let's check it. Now everything is fine because there is no green, no gray line. Gray means something is disconnected. Okay. Now 9 minus 5. Your result will be 4, right? 9 minus 4 is equal to 4. And let's say 15 minus 5. Your result is 10. 10 means A. 15 minus 10. Your result is 5. Can you see that?
Yes, sir.
Okay. What was the example we were doing? We're actually doing 1101. What does that mean? 12, 13, right? 1101. And
Yes, sir.
Okay. And what was that? 1011. 1011. Let's check this. 1011 means what? Okay. 1101, right? This is 1101. That means D. And the next one will be 1011. This one, 1011, right? Your result is what? Your result is 2. And if I change these ground, you will see this line will be red. See, if I click D and B, your result is 2, but this line is red, right? Because there was a bit there, that is we are ignoring. This bit, that bit is 1, and that is red. 1 means red, right? Here this is red, that means this is 1. So if you give this to your output, the result will be different. তুমি যদি এটা তুমি আউটপুটে দাও, if you give this in your output device, your result will be wrong. What do I mean by that? I mean these. If we use a display like this, if we use a big display like this, D minus B, your result is supposed to be You're supposed to be 2, right? That is correct. But if you give this, if you connect these with your result, now your result will be different. See, D minus B, your result is 12, not 2, right? That is a wrong result. That's why you need to ignore the carry. Always remember, you need to ignore the carry in case of subtractor. So I hope you will practice this at your home, and in the next class we will be adding this the addition, that is adder and subtractor together, and we will make a device that can do addition and subtraction both in the same circuit. Okay, in the same circuit, that can do the addition and subtraction both in the same single circuit. Okay,
Okay, sir.
that will be called adder subtractor, because here if I want to do the addition, what I have to do, I need to delete all the not get, delete. I need to connect them directly. I need to delete these 1, and I need to use the ground, and I need to connect this CO to my output. That time it will do the addition. And again, if I do the subtraction, then I need to delete this connection. I need to add some not get, and I need to delete this ground. I need to add this one, and I need to delete this connection again. So this is a mess. So you cannot do addition subtraction here. You need to change it every time you use it. So next time we will be making one single circuit that can do addition and subtraction both at the same time. Okay, that will be called adder subtractor. Okay, everyone.
Okay, sir.
Okay, wait, do not go. 1 minute. Okay, see you in the next class. Do you have any question? You can ask me in the Facebook. What is that Facebook? What is that Facebook chat box? Okay, you can ask.
Okay, sir.
Okay.